Hey everyone, so it's week 3. We are still focusing on triangles, but today we're going to focus on the side lengths and the angle measures in a triangle and how they're related to one another. So as we move through 3 examples, I want you to focus on this question. What do you notice about the sizes of the angle measures and the lengths of the sides? Okay, so hopefully after these 3 examples, we can come up with a general rule to help us with all triangles that we can use to help solve any questions. So moving on to example number 1. Okay, so here's our first example. This is triangle ABC. So first things first, we're going to start with the easiest. We're going to measure the side lengths. Okay, so I'm just going to take a ruler. I'm going to measure using centimeters, and I'm just going to estimate. So side BC is about 4 1/10 centimeters. Side AC is approximately about 9 centimeters. And AB is approximately 10 centimeters. Okay, so moving on to the angles, we use a protractor to measure the angles. Some of you may have worked with protractors last year. If not, no worries. You'll get more practice this year or even next year. So what we do is we use the protractor. We take the center part here, we put it on the vertex, and then we measure the angles. So this happens to be a 90-degree angle. So angle C is 90 degrees. And again, remember, after we measure these, they should add up to 180 if we measured correctly using the triangle sum theorem. So angle B is 66 degrees. And then angle A is 24 degrees. Okay, so now that we have all the measurements, I want you to kind of look and maybe see what you notice about these angle measures and their sides. Okay, so first things first, I want you to notice that measure of angle A is 24 degrees and the side BC is 4 1/10 centimeters. These are both the smallest measures on both sides, both the angles and the side lengths. And the relationship is that they are opposite one another. So angle A is opposite side BC. So if you want, you can even draw an arrow to show that they're opposite. Okay, and then angle B is 66 degrees, which is opposite side AC. So I'm just going to draw a line from angle B to side AC. And angle C is opposite side A. I'm just going to draw a line here. So again, that question that we're asking ourselves, what do we notice about these side lengths and their angle measures? So if you notice, again, angle C is 90 degrees, which is the largest angle measure. The side across angle C is AB, and that happens to be the longest side length. So there is a relationship between the angles and their opposite sides. Okay, so we're going to see if this holds true with all triangles. So we're going to move to example number 2. Okay, so example number 2, we're going to test our theory out from number 1 and see if it holds true. If the smallest angle is always opposite the shortest side, and if the largest angle is always opposite the longest side. So for example 2, I already measured the angles and wrote them down. Angle G is 30 degrees, angle H is 107 degrees, and angle I is 43 degrees. Okay, so these do add up to 180, so we know that it is a triangle. And now we're just left with measuring the side lengths. So I'm still going to continue to measure these in centimeters. So the first one is side HI. Since it is opposite angle G, so if we want to show that too, we can draw our arrow. Okay, so if our theory is true, since G is the smallest angle, side HI should be the shortest side length. So let's go ahead and measure. Again, we're just going to estimate. So this is estimated to about 7.5. centimeters. Okay, and again, angle H is 107 degrees, so that's our largest angle. So the side opposite that should be the longest side. So here's angle H. If we draw a line opposite the to the side, it is side GI. So this should be the longest side here. So let's go ahead and measure. So again, we're still measuring in centimeters. This is approximately 14, I'm going to say 14 and a half. Okay, and we still need one more. The angle opposite, the angle I is opposite side GH. Okay, and this one is 43 degrees. So HI is measuring at, I'm gonna say, oh, sorry, that's inches. I was wondering why that wasn't making sense. So HG is about 10 and a half centimeters. Okay, so let's go ahead and look. Does our theory hold true? Is the smallest angle opposite the shortest side? So here, 30 degrees, 7.5 centimeters. So far, that's good. Is the largest angle opposite the longest side? So largest angle here is 107 degrees and 14.5 centimeters, which does happen to be the longest side. So let's try one more example to see if our theory holds true. So example number 3. Okay, so example number 3, our last one, we have triangle DEF. So triangle DEF. Okay, so on this one, I've given the side lengths already. I've measured them out. Side EF is 12.5 centimeters. Side DF is 6.6 centimeters, and side DE is also 12.5 centimeters. So just by looking at the side lengths, I know that this is an isosceles triangle because two sides are the same length. Now, what do you think is going to happen with our angle measures since these two sides are the same? Okay, so let's go ahead and draw our arrows across from these sides. So if we're looking at side EF, the angle opposite is angle D. All right, so we're going to just draw this little arrow here. Okay, the angle opposite DF is angle E. I'm just going to draw this line. And the side DE is opposite angle F. So we're just going to draw this here. All right. So with our theory, again, the shortest side being opposite the smallest angle, in this case, we have two that are the same. So these angle measures should be the same. So I'm going to take my protractor. First, I'm going to measure angle D, which is opposite EF. So angle D, which is exactly 75 degrees. So with these two being the same, their angles should be the same. So I'm going to go ahead and measure angle F and see if I do get 75 degrees, which is exactly 75 degrees. Okay, and then since this is our shortest side, okay, this should be our smallest angle. So angle E, if we measure this one, it is, let's see, 30 degrees. All right, so that does hold true. The smallest angle measure is opposite the shortest side, and since these two are the same, there's no longest side, but the angles are actually the same measurement because the side lengths are also the same. So, okay, so coming back to this question here, what do you notice about the sizes of the angle measures and the lengths of the sides? What you should have noticed is that the smallest angle, okay, is always opposite the shortest side, and the largest angle is always going to be opposite the longest side. So I'm going to show you what this might look like when we apply it to problems, and I'm going to use a couple of examples from the textbook. Okay, so number 1 says the triangle ABC has side lengths 11, 16, and 19. Match each side with its correct length. So again, if we're using that rule, we know that the shortest side should be opposite the smallest angle. So again, what I like to do is to make sure I'm going to draw these arrows. So if this is the smallest angle, angle A, the side opposite is side BC. So it should be the shortest length, which happens to be 11. So BC is 11. And then I like to find the largest angle. In this case, this happens to be angle B, which is 88 degrees. And the side opposite it is side AC. So that should be the longest length from our rule. So the longest is, if we mark out 11, would be 19. So side AC is 19. And then the only one left over is side AB, which is 16. Okay, number 2, triangle ABC has the angle measures 45 degrees, 58 degrees, and 77 degrees. Match each angle with its correct measure. So now we're given the angle measures and we just need to match the correct side. So again, I always like to start with the smallest angle. So here, the smallest side is side CA. And if it's opposite the smallest angle, if we draw our arrow to the opposite side, or angle, it should be angle B. And our smallest measure out of 45, 58, and 77 is 45 degrees. So angle B has to be 45 degrees. If we look at the longest side, it's side AB, and the angle opposite is angle C. So if this is the longest side, this has to be the largest angle measure, and we're left with 58 and 77. So 77 is the largest there. So angle C has to be 77, and the leftover angle is angle A, which is 58 degrees. So hopefully this helped. I'm going to put a couple more examples in the in Schoology in the form of a Google form, and they're just for you to have extra practice. Have a good day.